So back in the project, and you see that we have our local branch and, as we just learned, our remote tracking branch in here. And as I said, if we add any changes here in our project and push or pull these changes, well, then these changes are first reflected in this remote tracking branch here, and then either in the local branch for a pull operation or in the remote branch if we pushed data to it. Now, let's maybe create another local branch here. Let's say we want to check out a new branch. Let's say this should be called feature. We know how this works in the meanwhile. So we have this branch, and if we run git branch, you see we have these two local branches. Let me clear this. If we run git branch -r, we see our remote tracking branches, and we didn't create one so far because the feature branch is just a local branch at the moment. If we want to see all branches again, we can run git branch -a. This lists all local and remote tracking branches. However, in this feature branch, we could now create a folder, as we always did it, called feature. And in here, we could create another commit, maybe f1.text. And we then add this and commit the changes, f1 here. Okay. And again, as you can imagine, nothing changed from our branch perspective. Now I could do the following. Now I can run git push. And as I said, now we have to specify where we want to push these changes to. Well, we again want to go to our origin location, right? So the location of our remote repository. And there we want to create a new branch named feature. So we reflect the local branch structure in our remote repository, so to say. Let's do this now. So we see we created a new branch in here. And if we now run git branch -a, then you see that we have this new remote tracking branch. With this push operation, we created this remote tracking branch, and we also created then a new remote branch in our GitHub repository. And if we now go to this repository and into our master branch, then we can switch between the branches here with this button. And you see we suddenly have a feature branch in here. And if we click onto these two dots right here, you see that in this feature branch we have our master folder, and we have this feature folder, which now contains this file that I just created. So that's the flow if we have a local branch and if we want to bring this local branch to our remote repository. But what happens if we create a branch here in GitHub in our remote repository? Well, we can also try this. For that, click onto this branch right here, and now you can find or create a branch. So we can say we create a feature remote branch, so to say. So a feature branch created in the remote repository. We can confirm this with enter. And now we have this new branch. You can see it right here. And we can now click onto these two dots once again. And we could create maybe a new file in here. Let's say we click it right here, and we call it remote.txt, so created here remotely. Then we can scroll down and commit this file. So we say file added on GitHub. And we want to add this commit directly to the feature remote branch. That's okay. So let's commit this new file now. With that, we can switch back to our command prompt. And in here, if we clear this, if we run git branch -a, you see this new branch is not reflected here. Well, if you want to have a list of all branches, and as I said, git branch -a here only lists the local branches and the remote tracking branches. But if you also want to see any remote branches you might have, then you can run git ls, so list -remote. A network call is made. And in here, you can now see the remote feature branch, the remote feature remote branch, so the branch we created, and the master branch we have on our remote repository. So this is kind of the proof that we have this branch here available. But how can we now get this information to our local project? Well, I showed you this git pull and git fetch commands on the slide. So if you just want to update your latest state without merging anything into your existing structure, you can just run git fetch. But if you just run git fetch, Git doesn't know what it should fetch at this stage. So you can simply say git fetch origin, like this. If you do this, You see that we have a new branch created here, the feature remote branch, and with git branch -a, you see we now have this remote branch available here in our project. By the way, what would happen if we would now run git pull instead of git fetch? As I said, git pull is a combination of git fetch and then of merging the remote changes into our local branch. Now, if we run git pull here, you see we get kind of an error, so to say, because we just pulled remote, but we did not specify any branch. And if you want to merge, well, something in Git, then you need to specify a branch it should be merged to. So this means if we would say git pull origin master, for example, right? Then this would work, it's already up to date, but then we would tell Git to fetch from the remote tracking branch into our local branch. As we didn't specify anything like that, in our initial git pull origin command, this is not working. So that's important to understand. Git fetch origin works because it updates the remote tracking branch, so these branches here. Git pull only works if you have a direct connection to a specific branch locally here, because otherwise Git doesn't know where it should merge it to. Now let's change something in our feature remote branch here. So let's go back to GitHub. Here I am in the feature remote branch, as you can see it. And now let me add another file, maybe remote2.txt, something like this. And let's say change done in remote branch right here. And this change should be committed directly to the feature remote branch. So we commit this now. And we have the file here. Let's now switch back to our local environment. And let's now maybe again try git fetch origin as we just did it. Like this. Yeah, we see something was updated. But if we now check our branches and for example the feature branch and check the login here, we see, well, we have only this F1 commit, but we don't have this latest changes implemented here. On the other hand, if you scroll up a bit, and take this branch's name, so that's the full remote tracking branch's name. So this branch is named remotes origin feature. So if we take this and check out this branch like this, you see we are in the detached head state. This is nothing new for us. So as I said, these remote tracking branches are not to be edited. These are just here to check for information as a first step. So to retrieve the latest state of our remote branch here in this case. And you see we have these two text files in here. And what we could do now, of course, is we could follow our good old approach and create a new branch in here with our git switch command, which then contains these changes. Yes, you can do this, but there actually is a better approach to incorporate changes from the remote tracking branch into our local branch. For this, I'll first check out the feature branch once again. So we are back here, and now, well, we have to explore one last type of branch, and that's not the remote tracking branch, but the local tracking branch. What's this now? Time for another branch types overview, because we are almost at the end when it comes to branches, but this last type is really crucial to understand how this whole Git and GitHub thing works. Let me quickly summarize what we had so far. We have a local branch. Well, nothing new to you. That's a branch on your machine only, as seen throughout the majority of the time we had together in this course. We also have a remote branch. We just learned this. A remote branch is a branch in a remote location. So for example, in GitHub. So you only see the remote branch if you are on GitHub or if you run the git ls-remote command we just saw. These are the only two ways to see these remote branches. Besides these, we have other branch types. These are so-called tracking branches. Tracking branches are all about exchanging information, so to say, between our local branch and the remote branch. We had a look at the remote tracking branch already. This was this red written branch, so to say, and this branch is just a local copy of the remote branch and not to be edited. We can, for example, get the latest state of the remote branch into the remote tracking branch with the git fetch command as we saw it. Now we could check out such a remote tracking branch and then create a new branch to have these latest changes also not in detached head state. But actually, if you think about the logic between the local branch and the remote branch and the remote tracking branch being in between, well, then we can actually just use another branch type to make this a bit more, well, efficient, so to say. And that's the local tracking branch. Now, what's this now? Well, the local tracking branch is a local reference to a remote tracking branch, and it's supposed to be edited. Local tracking branches not necessarily have to be references to a remote tracking branch, but for many cases, and also the cases we have a look at in this course, this is the case. Now, in this local tracking branch, commands like git push or git pull are available, also git fetch, of course. And the logic now is that our remote tracking branch gets the latest information from the remote branch. The local tracking branch is connected to the remote tracking branch, and with that also has the latest changes incorporated. We can then edit our local tracking branch, and once we're done, we can push these changes to the remote tracking branch, and with that, we can push changes to the remote branch on GitHub. Sounds a bit complicated, therefore we should have a little bit of a closer look at this now. How are local and remote tracking branches connected? Well, again, we have the remote branch in the cloud, and we know that with git fetch, we can update information that we have in the remote branch in our remote tracking branch. This remote tracking branch is a local copy of that remote branch, but not supposed to be edited. So in the end, it's just a local cache of the remote branch's content, so to say. And now things become even better, because in the example we just saw, we had the construct of having a remote branch, so this feature remote branch we created on GitHub. Then we have the remote tracking branch we just explored with the detached head. And then one thing was missing, and that was the local branch named equally. As I told you, you could create a new branch by creating a new branch based on the remote tracking branch, but you can actually create local tracking branches based on remote tracking branches, and we'll learn in the next lecture how this works. And if that's the case, then we can just merge the changes from the remote tracking branch into this local tracking branch. And with that local tracking branch, which is directly connected to that remote tracking branch, we can also omit the repository's name and the branch name. So instead of telling Git to pull origin master, we can just say, hey, git pull, or alternatively, git push. This means update my local tracking branch changes in the remote tracking branch, and with that, also update the remote branch. So that's again a lot of theory and not easy to digest. Therefore, let's have a look at this concept now from a practical perspective in the next lecture.